Assalamu alaikum. Welcome to lecture number 31 of the course on statistics and probability. You will recall that in the last 15 lectures, we discussed basic probability theory. We started from the basic definitions of probability and we went on to discrete and continuous probability distributions. Also, we considered the bivariate situation and we considered the coefficient of correlation. Students, in today's lecture, we begin the third and last segment of this course, and that is inferential statistics. That branch or that part of statistics which enables us to draw conclusions about real-life phenomena on the basis of real data that we have collected on sample basis. Now, as you see on the slide, there are two branches of inferential statistics. Statistical inference can be divided into the two main areas of statistical inference are estimation and hypothesis testing. Estimation itself can be divided into two types, point estimation and interval estimation. I will be discussing with you, first of all, point estimation, then we'll go on to interval estimation, and after that, we will discuss the other way of doing statistical inference, and that is hypothesis testing. But students, before I talk about any of these, the most important point to be noted is that there is a concept called sampling distributions, and this concept forms the basis for both estimation and hypothesis testing. So, in today's lecture and in the next lecture, we will be concentrating on this fundamental concept, that of sampling distributions. As you now see on the screen, the probability distribution of any statistic, such as the mean, the standard deviation, the proportion of successes in a sample, this is known as its sampling distribution. Students, now let me explain this point to you in some detail. मैंने कहा, the probability distribution of any statistic is called its sampling distribution. और आपको याद होगा कि इस कोर्स के आगाज में मैंने आपके साथ ये लफ्ज शेयर किया था. I said to you that there is a word called statistic, यानी statistics नहीं, just statistic. And what was that? Any quantity such as mean, median, standard deviation, any quantity that you compute from a sample, that is called a statistic. इस वक्त हम ये बात कर रहे हैं कि वो तमाम तर जो inferences हमने ड्रॉ करने हैं, conclusions जो हमें ड्रॉ करने हैं about the population, they are going to be based on that sample, that one sample that we will draw from the population. तो इस population से जो sample हमने draw कर लिया, अब हमारे पास तो सिर्फ ये sample available है ना, और इस sample data ही के साथ हम जो करना चाहें कर सकते हैं. And we will be computing the mean or the proportion of successes, whatever success may be, and median and so many other quantities, whatever we are interested in from this one sample. बात ये हो रही थी that the probability distribution of any statistic computed from the sample is called its sampling distribution. And students, I will explain this concept to you with reference to an example in considerable detail, ताकि आपको किसी किस्म की कोई confusion बाकी न रहे. As you now see on the slide, Let us examine the case of an annual Ministry of Transport test to which all cars, irrespective of age, have to be submitted. The test looks for faulty brakes, steering, lights, and suspension, and it is discovered after the first year that approximately the same number of cars have 0, 1, 2, 3 or 4 faults. Students, सबसे पहले इस सिचुएशन को समझने की कोशिश करें. यानी मिनिस्ट्री ऑफ ट्रांसपोर्ट ये टेस्ट कंडक्ट करती है. उस मुल्क में ये लॉ है कि आपको कार्स जो हैं दे हैव टू बी टेस्टेड, और ये 4 चीज़ों के लिए टेस्ट करते हैं. लेकिन उन्होंने देखा आफ्टर अबाउट अ ईयर कि जितनी कारें उन्होंने टेस्ट की, नो फॉल्ट या 1 फॉल्ट या 2 या 3 या 4 के चारों की चारों ही चीजें खराब हैं जो वो टेस्ट कर रहे हैं. ये पांचों जो वैल्यूज हैं एक्स की, वेयर एक्स रिप्रेजेंट्स द नंबर ऑफ फॉल्ट्स इन द कार, दे फाउंड दैट दीज 5 वैल्यूज आर इक्वी प्रोबेबल. ये लफ्ज मैंने जो इस्तेमाल किया उस पर गौर कीजिए. स्टेटमेंट जो अभी मैंने पढ़ी उसमें तो ये नहीं था. उसमें तो ये था ना कि दे फाउंड दैट approximately the same number of cars have 0, 1, 2, 3 or 4 faults. लेकिन मैंने इसको इस तरह से प्रेजेंट किया कि उसी relative frequency definition of probability की रूह से जिस पे हम काफी डिस्कशन कर चुके हैं, that we can say that these 5 values of x 0, 1, 2, 3, 4, 5 they are equiprobable. And if you agree with this explanation, then students, we can talk about the probability distribution of the population. Sample की बात तो बाद में होगी. पहले we talk about the probability distribution of the population. The population of those many cars that are going to undergo this particular test. So, as you now see on the screen, the probability distribution of the population is the column of X represents the number of faulty items in a car, and this number goes from 0 to 4, and the probabilities are 1 by 5, 1 by 5, 1 by 5, 1 by 5, and 1 by 5. The reason being that, as I just said, these 5 values are equiprobable. Now, in order to find the mean and the standard deviation of this particular probability distribution, of course, we resort to the same method that we had before. We multiply the x column with the column of f of x, where f of x, of course, represents the probabilities. And multiplying the two and adding, we find that sigma x into f of x is equal to 2. Also, to find the variance of this distribution, we construct one more column, and that is x square into f of x, and the sum of that particular column comes out to be 30 over 5, and that is 6. Now, the mean of any discrete probability distribution is sigma x into f of x, and therefore, the mean is equal to 2, but the variance is given by e of x square minus e of x whole square, as we have discussed earlier, and hence, the variance of this particular probability distribution comes out to be 6 minus 4, and that is 2. Taking the square root of this quantity, the standard deviation of this particular probability distribution is equal to 1.414. Students, हमने ये जो population है ना, इसकी distribution के बारे में बड़ी अहम बातें और अहम points मालूम कर लिए हैं. We know that it is a distribution that is discrete, because number of faults in a car can be 1 or 2, लेकिन 2.25 faults तो नहीं होंगे. And we know that the mean number of faults is 2, and we also know that the standard deviation of this distribution is 1.414. What about the shape of this distribution? Students, I hope that you have all answered my questions spontaneously and said that it is a discrete uniform distribution. After all, आपको याद नहीं कि हमने discrete uniform distribution पे substantial बहस की थी, and we noted that whenever the probabilities are equal, we get a uniform distribution. चलिए, population के बारे में तो एक clear idea हमारे जहन में build हो गया है. What are we wanting to do, students? We are wanting to talk about all possible samples of a particular size that I can draw from this population. Why? Because, as I said earlier, ये जो inference होना है, ये जो तमाम तर area है of statistics, वो क्या है? To draw conclusions about this population that we have on the basis of a sample. तो जाहिर है कि जब हम एक real life research करेंगे, उस वक्त तो हम सिर्फ एक सैंपल ड्रॉ करेंगे, बट सैम्पलिंग डिस्ट्रीब्यूशन का कॉन्सेप्ट समझने के लिए वी हैव टू कंसिडर नॉट जस्ट वन बट ऑल पॉसिबल सैंपल्स दैट यू कैन ड्रॉ फ्रॉम एनी पर्टिकुलर पॉपुलेशन. Sampling can be done in two ways: sampling with replacement and sampling without replacement. Sampling with replacement क्या होती है? You draw an element out of the population, you note down its main features and you replace it into the population. और sampling without replacement क्या है? You draw an element out and you throw it away. यानी मेरा मतलब है कि you do not put it back into the population before drawing the next element. तो स्टूडेंट्स, सैम्पलिंग डिस्ट्रीब्यूशन का जो कॉन्सेप्ट है, वी विल बी डिस्कसिंग दिस विद रेफरेंस टू बोथ सैम्पलिंग विद रिप्लेसमेंट एंड सैम्पलिंग विदाउट रिप्लेसमेंट. ये जो मैंने आपसे अभी पहले कहा कि वी हैव टू कंसिडर नाउ ऑल पॉसिबल सैम्पल्स दैट कुड बी ड्रॉन फ्रॉम दिस पॉपुलेशन ऑफ एनी पर्टिकुलर साइज. ये बात भी इस रेफरेंस से कि या तो वो तमाम तर सैंपल्स जो ड्रॉ किए जाएंगे दे विल बी विद रिप्लेसमेंट और या they will all be without replacement. So in this example that we are considering, let us suppose that the Ministry of Transport decides that they will just be testing 2 cars at a time, यानी sample size जो है that is 2. ये मैंने इतना छोटा सैंपल इसलिए लिया है स्टूडेंट्स ताकि इस कॉन्सेप्ट को समझने में आपके लिए आसानी हो. नाउ स्टूडेंट्स, in this scenario that we are discussing, we are actually talking about sampling with replacement. और इस पॉइंट को मैं कुछ देर के बाद ज्यादा तफसील से एक्सप्लेन करूंगी, लेकिन फिलहाल आप ये नोट कीजिए that whenever you are drawing a sample of size small n from a population of size capital N, and if you are doing sampling with replacement, the total number of possible samples that can be drawn in this manner, that number is capital N raised to small n, as you now see on the screen. In this example, capital N can be regarded as 5 and small n, the sample size is 2. And 5 square, capital N raised to small n, gives us 25. The 25 possible situations are, as you now see on the slide, they are 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Similarly, 1, 0, 1, 1, 1, 2, 1, 3 and 1, 4. और इसी तरह चलते जाइए हत्ता के हमें आखिरी सिचुएशन मिलती है which is 4, 4. अच्छा, अब यहाँ पे आप कंफ्यूज होने की यकीनन कोशिश कर रहे हैं. बिल्कुल ही कोई ज़रूरत नहीं है कंफ्यूज होने की स्टूडेंट्स। मैंने ये जो 25 सिचुएशंस आपके सामने प्रेजेंट की हैं, ये वो हैं कि जब दो कार्स को आप स्टॉप करें बाय द रोड साइड एट रैंडम और उनको टेस्ट कर लें फॉर दीज 4 थिंग्स, faulty lights, suspension and the other 2 that I mentioned earlier. तो अब ये 25 मुमकिना सिचुएशंस हैं। 0-0 का क्या मतलब है कि वो जो पहली कार है उसमें भी there is no fault और जो दूसरी कार है उसमें भी no fault. And what is 1-3? 1-3 का मतलब हुआ कि जो पहली कार रोकी गई that has one fault out of those 4 things. And the second car that you stopped, that has 3 faults. So, is tarah, I'm sure you will agree now that these are the 25 possible situations. Last situation मैंने अर्ज किया कि 4 है, यानी दोनों की दोनों कारें जो हैं उनमें चारों की चारों चीजें खराब है. Now, as I just said a short while ago, कि n raised to n, capital N raised to small n, ये number of samples होता है when we are sampling with replacement. यहाँ पे ये आप कहेंगे कि what do you mean? आप एक कार को निकाल के तो फिर से कार को वापस डाल तो नहीं रहे ना? Yes, you're right there, students. लेकिन आप इस point को इस तरह से understand कीजिए कि अगर हमारे पास एक hat है और हमने 5 पर्चियों पे ये 5 नंबर अलग अलग लिख दिए 0, 1, 2, 3 and 4 और उन पर्चियों को फोल्ड करके उस हैट में डाल दिया and then we shuffle or shake the hat and we draw one of those slips and suppose it says 0. हमने उसको वापस डाल दिया and then I again shake it and then I draw another one and once again it is 0. Students, चूंकि ये with replacement है ना कि मैंने वापस डाल दिया था, इसीलिए ये possible हुआ कि दूसरी मर्तबा भी I could get a 0 and therefore I get the pair 0, 0. देखा आपने? This is the way to understand the point कि अगर आप without replacement करते तब तो आप 0, 0 आपको नहीं मिल सकता था. अगर पहली मर्तबा में 0 निकल आया and you have thrown it out of that hat, तो अब तो उस hat के अंदर सिर्फ 4 पर्चियां बाकी हैं 1, 2, 3, 4. तो अब तो next time you can either get a 1 or a 2 or a 3 or a 4. Now, what is the total number of possible samples that can be drawn without replacement from a population? Students, the answer is capital N, C, small n. आपको याद नहीं? When we were discussing the rules of permutation and combination, उस वक्त combinations rule की discussion के हवाले से मैंने आपसे यही कहा था ना that if you want to draw R things out of N things without replacement, वहाँ अगर ये लफ्ज नहीं भी कहा students, तो it was implied. क्योंकि आम जिंदगी में जब आप निकालते हैं ना, तो आप without replacement ही निकालते हैं. आप 10 स्टूडेंट्स बैठे हैं क्लास में, उनमें से 2 स्टूडेंट्स को लेकर जाना है हमने सेमिनार पे, तो हम यूं तो नहीं करेंगे ना कि एक निकाला वापस डाला और दोबारा भी वही निकाल लिया. So in real life, of course, most of the time we are dealing with situations when we are sampling without replacement. तो उस वक्त जब combinations rule की बात कही, तो यही आपसे कहा कि the total number of ways of drawing R things out of N things is NCR. Exactly यही formula आप यहाँ पे apply कीजिए. The population size is capital N and the sample size is small n, and the total number of ways of drawing samples without replacement of size small n from this population of size capital N, that number is NCN. And as you now see on the slide, in this example, NCN is equal to 5C2 and 5c2 is equal to 5 factorial over 2 factorial into 3 factorial, and that is equal to 10. So, if the population values are 0, 1, 2, 3, 4, then the 10 possible samples of size 2 drawn without replacement from this population are 0, 1, 0, 2, 0, 3, 0, 4, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4 and 3, 4. Students, आपने गौर किया कि ये जो 10 सैंपल्स हैं इनमें फर्स्ट एलिमेंट जो है दैट इज नॉट रिपीटेड. कॉमे से पहले जो एलिमेंट है, कॉमे के बाद उससे मुख्तलिफ एलिमेंट है, एंड दिस इज व्हाट यू विल ऑब्टेन whenever you are sampling without replacement. लेकिन इस वक्त हम वापस उसी एग्जाम्पल पे चलते हैं जो मिनिस्ट्री ऑफ ट्रांसपोर्ट वाला है, जिसमें they are just stopping 2 cars at random by the roadside and they are testing them. यहाँ पे स्टूडेंट्स सैम्पलिंग विद रिप्लेसमेंट वाला केस वैलिड है, क्योंकि वो कारें जो हैं दे आर इंडिपेंडेंट और मुमकिन है कि पहली कार में भी 0 ही फॉल्ट्स हों और दूसरी जो रोकी जाए उसमें भी 0 ही फॉल्ट्स हों, एंड सो यू गेट 0, 0 as one possible situation. So, as I said a few minutes earlier, in this kind of a scenario, the total number of possible samples is n raised to n, 5 raised to 2, and that is 25. And once again, if you see on the screen, the 25 samples are 0, 0, 0, 1, and so on, going up to 4, 3, and 4, 4. ये जो मिनिस्ट्री ऑफ ट्रांसपोर्ट है, इसका एम क्या है? ये इस वक्त हम ये अस्यूम कर रहे हैं कि हम ये जानना चाहते हैं या मिनिस्ट्री ये जानना चाहती है कि व्हाट इज द एवरेज नंबर ऑफ फॉल्ट्स पर कार इन दिस पर्टिकुलर सिटी. यानी जिस्ट ऑफ द होल स्टोरी कि हम म्यू में इंटरेस्टेड हैं. म्यू ऑफ कोर्स रिप्रेजेंट्स द मीन ऑफ द पॉपुलेशन. अब ये जो सैंपल्स ऑफ साइज 2 हम ड्रॉ कर रहे हैं, इनसे तो हमें म्यू नहीं मिल सकता ना. इनमें से तो किसी भी सैंपल का अगर आप मीन कंप्यूट करेंगे तो दैट विल बी एक्स बार. तो बात ही यही है कि एक्स बार जो है दैट विल बी एन एस्टिमेट ऑफ म्यू. और ये जो सारी डिस्कशन मैं इस वक्त कर रही हूं और आगे अगले लेक्चर्स में भी होगी, दैट इज इन दिस एरिया. एक्स बार जो हमें सैंपल से मिलेगा, जो म्यू की एस्टिमेशन करेगा. इस सिलसिले में कुछ इंतहाई अहम मैथमेटिकल पॉइंट्स जिनके अंडर सैम्पलिंग डिस्ट्रीब्यूशन का बहुत ज्यादा इंपॉर्टेंट कॉन्सेप्ट भी आता है, ये सब कुछ हम डिस्कस इस वक्त कर रहे हैं. ऑलराइट, we have 25 samples and we are interested in the mean. So, students, let us compute the mean of each one of these 25 possible samples. इतना छोटा सैंपल साइज है, सिर्फ 2 वैल्यूज हैं. You just have to add the 2 and divide by 2. And as you now see on the screen, the 25 sample means are 0.0, 0.5, 1.0, 1.5, 2.0, and so on. And the mean of the last possible sample is 4 plus 4 divided by 2, and that is 4.0. आपने नोट किया कि इन मीन्स में से कुछ मीन्स ज्यादा मर्तबा अकर कर रही हैं और कुछ कम मर्तबा. सो नेचुरली जहन में ये बात आती है कि अगर हम इन मीन वैल्यूज की फ्रीक्वेंसी डिस्ट्रीब्यूशन फॉर्म कर लें तो वी विल हैव अ बेटर आइडिया ऑफ द सिचुएशन. सो वी वुड लाइक टू डू एग्जैक्टली दैट, एंड एज यू नाउ सी ऑन द स्लाइड, द फ्रीक्वेंसी डिस्ट्रीब्यूशन ऑफ एक्स बार in this particular example is the column of x bar starts from 0.0 and goes up to 4.0, and the number of samples having these values of x bar are 1, 2, 3, 4, 5, 4, 3, 2, and 1. So that the sum of the column of frequencies is 25, and this is exactly the number of samples that we had. Dividing these frequencies by the total frequency 25, students, we obtain 1 by 25, 2 by 25, 3 by 25, and so on. And these numbers represent the probabilities of the various values of x bar. The probability that x bar will be equal to 0 is 1 over 25. The probability that x bar will be 0.5 is 2 by 25, and so on. Students, ये बात के ये जो हमने डिवाइड करके नंबर निकाले, they represent the probabilities. अगर आपको इसमें कुछ थोड़ी सी confusion है, तो आप उसी पुरानी बात पे जाइए कि अगर सारे आइटम equally likely हों, then the classical definition is valid. और यहाँ पे in reality ये probabilities जो हैं, they are occurring due to the classical definition. ये जो samples, all possible samples है ना, they are equally likely to be drawn. इनमें से कोई भी sample आ सकता है in a real life situation और equal chance है. इसलिए equally likely की condition पूरी होती है and we can apply the formula favorable over the total. And so जब हम देखते हैं कि 25 में से सिर्फ एक सैंपल है जिसका मीन 0.0 हो सकता है, तो इसका मतलब है कि only one of those 25 is favorable to what we want here, and so the probability that x bar will be equal to 0.0 comes out to be 1 by 25. And in a similar way, you can interpret all those probabilities. Students, this particular probability distribution that we have just constructed, this is called the sampling distribution of x bar. यानी एक बहुत simple concept, a column of x bar along with a column of probabilities such that the sum of the probabilities column is 1. यानी बिल्कुल वही पुराना concept. और इसलिए जो हमारी सबसे पहली definition थी, that is fulfilled. The probability distribution of any statistic is called its sampling distribution. अगर हम x bar की जगह x tilde यानी मीडियन की बात कर रहे होते और ये जो 25 सैंपल हैं इन सब के मीडियंस कंप्यूट करते और बिल्कुल इसी प्रोसीजर के जरिए जो मुख्तलिफ वैल्यूज हैं मीडियन की उनकी प्रोबेबिलिटीज कंप्यूट कर लेते, तो स्टूडेंट्स that would have been called the sampling distribution of x tilde. So I hope that you have no confusion whatsoever. The sampling distribution is a fundamental concept for statistical inference. Estimation और hypothesis testing दोनों में इसका कलीदी किरदार है और ये चीज हम डिस्कस करेंगे as we go on. At this point in time, I would like you to think of the shape of this particular distribution and also its center and its spread. After all, आपको पता तो है, हर वक्त हमें इन तीन चीजों में इंटरेस्ट होता है, the center or the location of our distribution on the x-axis, the spread which is a measure of variability. और variability वो चीज है जो अल्लाह ताला ने इस कायनात में हर तरफ रखी हुई है. After all, what is statistics? Students, statistics is the science of dealing with variability. Shape में हम बड़ा interested रहते हैं. Is it symmetric? Is it skewed? Let us look at the shape of this particular distribution. As you now see on the screen, if we plot x bar along the x-axis and the probabilities along the y-axis, we obtain the vertical line segments which yield an absolutely symmetric triangular distribution. Now, आपने देखा कि बिल्कुल ही सिमेट्रिक है और ट्रायंगुलर है. What will be the mean of this distribution? I think you will agree that I don't have to apply any formula. I just simply locate the center of this distribution that we have on the slide, and we find that the mean is equal to 2. But then what about the spread? उसके लिए अब थोड़ा सा प्रॉब्लम है. स्प्रेड के लिए तो शायद हमें एक्चुअल फॉर्मूला कंप्यूट करना ही पड़े. So what is the formula by which we can compute the spread, the standard deviation, or even the mean of a distribution of this type? As you now see on the slide, students, we have already learnt that in the case of the probability distribution of x, mu is given by sigma x into f of x, and the variance is given by sigma square equal to e of x square minus e of x whole square, which is further equal to sigma x square into f of x minus sigma x into f of x whole square. But now, since we are dealing with the probability distribution of x bar, therefore, we replace x by x bar in these formulas, and hence we obtain mu x bar, that is the mean of the sampling distribution of x bar, is equal to expected value of x bar, which is equal to sigma x bar into f of x bar. Similarly, sigma square x bar, that is the variance of the sampling distribution of x bar, is equal to expected value of x bar square minus expected value of x bar whole square, and this is further equal to sigma x bar square into f of x bar minus sigma x bar into f of x bar whole square. Students, आपने देखा कि ये बहुत आसान है, कतई मुश्किल नहीं है. All you have to do is to replace x by x bar. पहले आपका x और f of x का कॉलम होता था, अब आपके पास x bar और f of x bar का कॉलम, and therefore you just replace x by x bar. Now let us try to find the mean and the variance of this particular sampling distribution. As you now see on the screen, when I multiply the x bar column by the column of f of x bar, which represents the probabilities of the various values of x bar, I obtain x bar into f of x bar is equal to 0, 1 by 25, 3 by 25, 6 by 25, and so on. And upon adding this particular column, the expected value of x bar comes out to be 50 over 25, and that is equal to 2. Similarly, in order to find the variance, I first need to find expected value of x bar square, and that is equal to the sum of the column x bar square into f of x bar. Therefore, I multiply the first column, that of x bar, by the third column, that is x bar into f of x bar, to obtain the fourth column, which is x bar square into f of x bar. And the values in this particular column are 0, 1 by 50, 6 by 50, 18 by 50, and so on. Adding these values, the expected value of x bar square comes out to be 250 over 50, and that is equal to 5. Now, substituting these values in the formula of the variance, I obtain the variance of x bar is equal to 5 minus 2 square, and that is equal to 1. When I take the square root of this particular quantity, it is obvious that the standard deviation of the sampling distribution of x bar is also equal to 1. Students, अब मैं आपको 2 या 3 बहुत ही अहम points बताने वाली हूँ. The first thing is that the standard deviation of the sampling distribution of x bar is called the standard error of x bar. और ये जो term है ना, standard error, this is widely known worldwide and it is a very, very important term. Standard deviation जो है हमारे distribution की, उसको हम कहते हैं standard error. अब यकीनन आपके जहन में ये सवाल आ रहा होगा कि एरर का लफ्ज कहाँ से आ गया. तो ऐसा करते हैं कि इस पर्टिकुलर सवाल को थोड़ा सा पेंडिंग कर देते हैं and I will pick it up later. Now the other very important point that I would like to convey to you is that there are certain relationships between the mean of the sampling distribution and the mean of the population, and between the standard deviation of the sampling distribution and the standard deviation of the population. As you now see on the slide, the first property is that mu x bar is equal to mu. Isme, on the left hand side, we have mu x bar, which represents the mean of the sampling distribution of x bar. And as you noticed a short while ago, in this example, mu x bar is equal to 2. Now, in this equation, on the right hand side, we have mu. और जब हम खाली mu कहते हैं, we are talking about the mean of the population. और आपको याद होगा, इस प्रॉब्लम के आगाज में हमने population का mean compute किया था, and that also was equal to 2. Hence, this equation is verified that mu x bar is equal to mu. Students, ये जो formula मैंने अभी आपको दिया, this is valid in the case of sampling with replacement and also in the case of sampling without replacement. अगर आप sampling with replacement करें तो 25 sample बने, 25 means आपने compute की, x bar की 25 values थीं, और हमने देखा कि mu x bar, the mean of the means, यानी मीनों की mean, that is equal to the population mean. अगर हम sampling without replacement करते तो 5C2 यानी सिर्फ 10 sample होते और सिर्फ 10 अदद sample means होती, but you would have found that the mean of those 10 means would also have been equal to 2. Now, the other extremely important relationship is between the standard deviation or the standard error of the sampling distribution of x bar and the standard deviation of the population. And as you now see on the slide, in case of sampling with replacement, sigma x bar is equal to sigma over square root of n. On the other hand, in case of sampling without replacement from a finite population of size capital N, sigma x bar is equal to sigma over square root of n, and this whole term is multiplied by the square root of capital N minus small n over capital N minus 1. The factor square root of capital N minus n over n minus 1 can be referred to as the finite population correction factor, and it is abbreviated to be called FPC. All right, अब तो कुछ बहुत ही complicated situation हो गई है ना? इतना confuse होने की तो ज़रूरत ही नहीं है. जैसा कि बहुत दफ़ा आपसे कह चुकी हूँ, just relax and approach the problem in a methodical manner. हमारी इक्वेशन विद रिप्लेसमेंट के केस में क्या थी? सिग्मा एक्स बार इज इक्वल टू सिग्मा ओवर स्क्वायर रूट ऑफ एन. और इस प्रॉब्लम में आपको याद होगा कि आगाज में हमने जो पॉपुलेशन हमारी थी उसका स्टैंडर्ड डिविएशन निकाल लिया था. एंड आई होप यू डू रिमेंबर इट वाज द स्क्वायर रूट ऑफ 2 एंड इट वाज 1.414. अब सैंपल साइज क्या है? 2. लिहाजा ये जो इक्वेशन है इसकी राइट हैंड साइड क्या है? सिग्मा ओवर स्क्वायर रूट ऑफ एन. दूसरे लफ्जों में 1.414 ओवर स्क्वायर रूट ऑफ 2, यानी 1.414 over 1.414, and that is equal to 1. But what is the standard deviation of the sampling distribution? Students, अभी चंद मिनट पहले हमने देखा कि sigma x bar is equal to 1. So this equation is verified. 1 is equal to 1, and therefore we have verified for this example this very important relation. अब जो हम इस वक्त एग्जाम्पल कर रहे हैं उसमें तो विदाउट रिप्लेसमेंट नहीं किया कर रहे, ये तो इक्विवेलेंट है उस सिचुएशन के व्हेन वी आर सैम्पलिंग विद रिप्लेसमेंट. लेकिन अगर आप किसी और एग्जाम्पल में सैम्पलिंग विदाउट रिप्लेसमेंट करें, देन यू विल फाइंड दैट सिग्मा एक्स बार विल बी इक्वल टू सिग्मा ओवर स्क्वायर रूट ऑफ एन मल्टीप्लाइड बाय द स्क्वायर रूट ऑफ कैपिटल एन माइनस स्मॉल एन ओवर कैपिटल एन माइनस 1, यानी द एफपीसी. स्टूडेंट्स, ये जो टर्म है कैपिटल एन माइनस स्मॉल एन ओवर कैपिटल एन माइनस 1, जैसे कि मैंने 2-3 बार कहा, दिस इज रिक्वायर्ड वेन एवर वी आर सैम्पलिंग विदाउट रिप्लेसमेंट फ्रॉम अ फाइनाइट पॉपुलेशन. मगर एक पॉइंट बहुत इंपॉर्टेंट यहां पे भी आप नोट कीजिए. इफ द सैंपल साइज इज मच मच स्मॉलर देन द पॉपुलेशन साइज, फॉर एग्जाम्पल if capital N is 1000 and sample size small n is only 2, इस सिचुएशन में ये जो टर्म है ये किस चीज के बराबर होगी? कैपिटल N माइनस स्मॉल n ओवर कैपिटल N माइनस 1 इज इक्वल टू 1000 माइनस 2 ओवर 1000 माइनस 1, यानी 998 divided by 999. And students, you will all agree that this is equal to 0.99 something, and that is approximately equal to 1. So this means that whenever the population size is much larger than the sample size, this term is almost equal to 1, and we do not need to apply it. क्योंकि 1 से multiply करने का तो यही मतलब है ना कि आप बेशक वो ना लिखें. तो इस सिलसिले में as a rule of thumb आप ये बात जहन में रखें कि if the sample size is less than 5% of the population size, then you don't need to apply this term. But if the sample size is greater than 5% of the population size, then you should attach this term to the other part, sigma over square root of n. All right. What are we wanting to discuss in this lecture? We are talking about the sampling distribution of x bar. अभी हमने sample size 2 के लिए देखा कि हमारी sampling distribution triangular है, उसका mean बिल्कुल middle में है obviously, और उसका standard error जो है उसकी भी एक relationship है with the population standard deviation. मीन की तो नहायत इंटरेस्टिंग रिलेशनशिप है. जैसे मैंने पहले कहा कि सैंपल मीन्स का मीन पॉपुलेशन मीन के बराबर होता है. स्टूडेंट्स, जो प्रॉपर्टी मैं आपके साथ अब डिस्कस करने वाली हूं, दैट इज ऑफ क्रूशियल इंपॉर्टेंस इन स्टैटिस्टिकल थ्योरी, और वो ये है कि व्हाट हैपन्स टू द शेप ऑफ आवर सैम्पलिंग डिस्ट्रीब्यूशन इफ the sample size is increased. अभी जो एग्जाम्पल था उसमें तो it was an extremely small sample size. It was only 2. आइए देखते हैं कि हमारी सैम्पलिंग डिस्ट्रीब्यूशन की शेप किस तरह से ट्रांसफॉर्म होती है as we increase the sample size. Suppose that the Ministry of Transport decides to test at any particular occasion not just 2 cars but 3 cars. दूसरे लफ्ज़ों में अब हमारा sample size 3 है. And according to the formula that I presented earlier, the total number of samples of size 3 that can be drawn with replacement from a population of size 5 is equal to capital N raised to small n, that is 5 raised to 3, and that is 125. Students, अगर इन 125 सैम्पल्स के लिए हर सैम्पल का आप मीन कंप्यूट करें और फ्रीक्वेंसी डिस्ट्रीब्यूशन बनाएं और प्रोबेबिलिटीज निकाल लें exactly the same way as we did earlier, then you obtain the sampling distribution of x bar that we now have on the screen. This time the values of x bar are 0.00, 0.33, 0.67, 1.00, and so on. And the frequencies are 1, 3, 6, 10, 15, 18, 19, 18, 15, 10, 6, 3, and 1. Dividing each of these numbers by 125, we obtain the probabilities. And when we plot these on a graph paper, we find that even now our distribution is absolutely symmetrical. But it is very important to note that unlike the earlier one, which was triangular, this particular distribution is more like a normal distribution. Students, I would like to encourage you to work on this problem on your own. यानी आप size 5 की जो population है ना, 0, 1, 2, 3, 4, उसमें से आप all possible samples of size 3 खुद निकालिए with replacement. तो क्या आएंगे samples? The first possible sample will be 0, 0, 0. यानी उन कारों के हवाले से हम यूं समझें कि वो तीनों कारें जो स्टॉप की गई बाय द रोड साइड, उनमें से किसी भी कार में कोई एक फॉल्ट भी नहीं पाया गया. एंड द सेकेंड पॉसिबल सैंपल विल बी 0, 0, 1. यानी पहली 2 कारें तो सही निकली, बट इन द थर्ड वन देयर वाज 1 फॉल्ट. एंड स्टूडेंट्स, यू हैव टू गो वेरी सिस्टमैटिकली, क्योंकि अगर आप सिस्टमैटिकली नहीं चलेंगे तो देयर इज अ प्रोबेबिलिटी दैट यू माइट गेट अ बिट कंफ्यूज्ड. So I would like to help you a little. 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3, 0, 0, 4. अब इसके बाद क्या करें? Should we talk about 0, 1, 0, 0, 1, 1, 0, 1, 2, 0, 1, 3, and 0, 1, 4? Yes, I think we are going in the right direction. आप इसको जरूर एक मर्तबा खुद कीजिए. It will take quite a bit of time, but I assure you, if you go through this exercise once, you will acquire a sense of confidence and you will feel at home with this idea. How do we obtain the various x bar values that you just saw on the screen? The first one was 0.00. वो तो खैर बहुत obvious है. वो जो पहला सैंपल है ना, 0, 0, 0, जाहिर है कि अगर आप इन 3 वैल्यूज को ऐड करें और 3 से डिवाइड करें, you will get a 0. But what about the second one? We have 0, 0, 1. और अगर इसका इन वैल्यूज का मीन लेना चाहें तो क्या आएगा? 0 plus 1 over 3. And how much is that? 1/3, and that is 0.33. And that is exactly the value we had on the screen as the second possible value of x bar. All right. Now that we have looked at the distribution of x bar for the case sample size equal to 3, let us also consider the sampling distribution for that case when sample size is equal to 4. यानी एक नंबर और ऐड कर लीजिए. इस केस में how many possible samples? n raised to n, 5 raised to 4, and how much is that, students? That is 625. So, if you want to draw samples of size 4 with replacement from a population of size 5, you have as many as 625 possible samples. अब मैं आपसे ये नहीं कहूँगी कि आप इसको खुद करें, because I know that now you will say that it's too much. 625 samples, the first of which is 0, 0, 0, 0, and the last one is also very simple, 4, 4, 4, and 4. लेकिन जो 623 दरमियान में है, that is a long story. But if you don't want to do it yourself, then please accept what I am conveying to you. As you now see on the slide, in this situation, we have a sampling distribution of x bar as follows. The values of x bar are 0.00, 0.25, 0.50, 0.75, 1.00, and so on. And the probabilities are such that when we plot this particular distribution, it is again absolutely symmetrical. As you now see on the slide, students, this particular one looks like a normal distribution even more than the one which we had in the case of sample size equal to 3. And this is exactly the point that leads us to one of the most important theorems in statistical theory. As you now see on the screen, the theorem known as the central limit theorem states that if a variable x from a population has mean mu and finite variance sigma square, then the sampling distribution of x bar approaches a normal distribution with mean mu and standard deviation sigma over square root of n as the sample size n approaches infinity. Now, you have noticed that according to the central limit theorem, अगर sample size infinity को tend कर जाए, तो हमारी sampling distribution normal को approach करती है. और अभी जो example मैंने आपके सामने पेश किया, उसमें आपने देखा कि infinity तो बहुत दूर की बात है. अभी सिर्फ हमने size 2, size 3 और size 4 को consider किया, और size 4 पे we saw that the distribution looked much more like a normal than what we had in the case of size 2. Now, as you see on the slide, as n tends to infinity, the sampling distribution of x bar approaches normality with mean equal to mu and standard deviation equal to sigma over square root of n. जैसा कि मैंने पहले कहा students, this is a theorem of fundamental importance. अक्सर औकात हम कह सकते हैं कि हमारी जो population है that will be something like a normal, क्योंकि अगर for example आप heights की बात कर रहे हैं या temperature या इस किस्म के phenomena, blood pressure वगैरह की बात कर रहे हैं, तो जैसा कि मैंने पहले discuss किया था, most of these phenomena are normally distributed. तो उस केस में तो इस थ्योरम की as such ज़रूरत ही नहीं है. लेकिन जाहिर है कि कई ऐसी situations होंगी where we cannot say that the population is normal, और उस केस में हम कैसे मालूम करें कि हमारी जो सैम्पलिंग डिस्ट्रीब्यूशन होगी उसकी क्या शेप होगी. This theorem comes to our rescue. We note that irrespective of the shape of the population, as long as the sample size small n is adequately large, the sampling distribution of x bar is going to be approximately normal with mean mu and standard deviation sigma over square root of n. And what happens in the case when the population itself is normal? Then we are better off. फिर तो ये है कि ये शर्त लगाने की भी ज़रूरत नहीं रहती कि सैम्पल साइज लार्ज हो. उस केस में as you now see on the slide, we have the situation that if the population sampled is normally distributed, then the sampling distribution of x bar will also be normally distributed regardless of the sample size. In other words, x bar will be normal with mean mu and standard deviation sigma over square root of n, even if sample size n is not very large. Students, in today's lecture, I discussed with you the fundamentally important concept of sampling distributions. We will be discussing this topic further in the next lecture, and in the meantime, I would like to encourage you to study various aspects of this concept in your textbook and in as many other books as you conveniently can. Until next time, best of luck and Allah Hafiz.